Hey, this is Mr. Coker with Algebra Lesson 5 correlation. There are different things we can talk about when we talk about correlation. Most of them I'm not talking about. I'm not talking about strong versus weak. If that's what you need, this isn't your video. I'm not talking about correlation versus causation. If that's what you need, again, not your video. I'm talking about, just keeping it very simple, positive, negative, none. So I'm going to keep this as simple as I can. Positive correlation. I've got two examples here. The first, generally, what we mean when we say positive or negative correlation is we go left to right. Does the cluster of numbers of data, is it getting bigger or smaller as we go left to right? Well, let's look. As we move left to right, notice how it's going up. This would be an example of, it looks like a linear equation. It just looks mostly like a straight line going up. As down when we're starting, the numbers, notice they're down here. They're low. They're even below zero. They don't have to be below zero, but they're lower when we start. And as we go to the right, they're just getting bigger. With the negative, the opposite is true. On the left side, we're up here. As we go to the right, it's going down. The y's are getting smaller. Those are the two that are related to linear equations. Now, below that, we have ones that are clusters of data that are related to exponential equations. The first is, hopefully remember this shape is exponential growth. You have an asymptote, almost straight line, curving, going up. Now, because as we go left to right, now right away it knows it's not getting bigger. That's because it's exponential, so there's an asymptote. But it then starts going straight up. That is positive correlation. The opposite is true on the negative side. Notice when we're on the left side, we're way up here, and on the right side, we went down, curved, and flattened out because, again, asymptote. So it can be hard sometimes to see the exponential ones, to see if those are positive or negative, namely if you're looking for linears. But it is the case that with exponential signs, you just have to look and see, does it look like an exponential? Last one is the none. Now, hopefully you see this and notice there is nothing here that looks like it's getting bigger or getting smaller or anything. There's just a bunch of random data points. They're all over the graph. Now, I've filled this thing up with points. But it's not getting bigger or smaller at any point. This would be no correlation. That would mean our data doesn't show us anything. It doesn't show, if we have a set of data, no positive correlation means the x's and the y's appear to be related to each other in some way. They have maybe it's coincidence, but they're correlated as in as the x's get bigger, the y's get bigger. As x's get smaller, or as x's get bigger, the y's get smaller in general with positive and negative. With none, as the x's get bigger, we have no idea. Sometimes it's bigger, sometimes it's smaller. There's no telling. The points are just all over the graph. So, positive, negative, none. Hope that's pretty easy, especially when you do the assignment on it. So, thanks for watching.